some fantastic problems this morning, and I want to see how you're going to do on them. See how your memory's holding up from the concept bite that we did and the new stuff. So problem number one, write the problem down. Remember, that's part of it, because then you can think through it as you're doing the problem. Is parentheses 6x to the third y to the fourth parentheses squared times x to the negative 2 power y. Go ahead and do that problem before we go on to the next one. I'll turn the lights up so you can see too. I hope the smart board is I'll probably crank that back down. Some of you might not have calculators. That might be helpful. Anybody over here need one? Anybody else need one? I have a couple more.
It's that number 11 at the end is number 2.
Number 2?
Top.
Are you ready for number 2? I'll read it out. Yeah, okay. Some of this is it's going to be hard to read this now. It's my chicken scratch. That's what it is. I can always read it off again. The top of this fraction says 20 x to the negative 2, y to the 8, z to the third. I put a line through my z's so they don't look like 2's. So 20 x to the negative 2, y to the 8, z to the third over 5x y to the 10th, z to the negative 1. So bottom of that fraction is 5x y to the 10th, z to the negative 1. Yeah, some of you are going to be faster than others. You could just keep going, and yeah, if you can't read something, you know. So, number 1, we had 6x to the third, y to the fourth, squared, x to the negative 2, y to the first, and we're going to multiply that out in the end. But order of operations says we have to take care of the power first. And because this is going to be multiplication in these parentheses, we can distribute that too. So that'll be 6 squared, and then you think when you raise a power to a power, you multiply. X to the 6th, y to the 8th, and then we still have our x to the negative 2, y to the first to deal with. So now we know what 6 squared is. That's 36. We just have to remember, well, what do you do when you're multiplying similar bases? You add the exponents. So 6 plus negative 2 is 4. 8 plus 1 is 9. So 36, x to the 4th, y to the 9th. Now when we did the concept bite, we were not talking about absolute value bars. So if you were thinking, Well, when we have x's and y's, aren't we supposed to always use absolute value bars? No, that was when we start talking about radicals that we had to do that. So during the concept bite, boom, that was it. So 36 x to the 4th, y to the 9th. Then the second one, 20 x to the negative 2, y to the 8th, z to the 3rd, over 5x, y to the 10th, z to the negative 1. So the big picture here is division. Treat numbers like numbers. 20 divided by 5, 4. Numbers are done. But when we divide similar bases, we subtract the exponents. So negative 2 minus 1, that's going to be negative 3. And then 8 minus 10, that'll be a negative 2. But 3 minus a negative 1 is going to be 3 plus 1, which is 4. And then we have to realize, well, that's not done because we have negative powers. Negative powers are reciprocals. Right now, this looks like this, because you guys remember, whenever you want to make a fraction, you just slap a 1 below it, and that makes it a fraction. But this one has a positive power. The 4 is going to stay up top. This one has a positive power. It's staying up top. It's just these two, the x and the y, that have to go down below to become positive. So 4z to the 4th over x to the 3rd, y squared. And now there's no more x's we can put together, or y's, or z's that we can put together, so that one is done. The third one had the negative stuff going on. 2x to the negative 2 over 3y to the 5th, all raised to the negative 2nd power. I had mentioned to you, I don't like negatives all over the place. And if we could distribute this negative 2 power up there, but then everything would have negative powers. So instead, what I do, take the reciprocal to get rid of that. So that means we're going to have 3y to the 5th over 2x to the negative 2nd, but now this is a positive 2 power instead, because the flipping makes it a reciprocal, and it makes it an easier problem. So then we see that we have multiplication and division in the parentheses, so we can just distribute that 2. That's going to be 3 squared y to the 10th over 2 squared x to the negative 4. And now no more power on the outside of those parentheses. So now it's like, well, what do we do inside? Well, we've got numbers. That's a 9. This is a 4. But we still have one issue. And that one issue is we have a negative for a power. So we're going to have to take the reciprocal of just that x term, because this little 4 right here, that's a first power. That's going to stay exactly where it is. It's just the x to the 4th that has to come up to the top in order to become positive. When I made this out this morning, I thought that's probably, if anybody's going to miss anything, that's probably going to be it. That one is a toughie. Then the fourth one, some of you went and did this problem right away. You're like, oh my gosh, I can't believe she put that on there. Well, yeah, we did that. We spent a couple of days doing that. And then number 5, this was the other one that I thought if anybody forgets anything, they're going to forget the absolute value bars. But we just did it yesterday, and you guys did great on this as I was wandering around spying on you. Oops, 121. There we go. So we think about how this is a square root of 121. That's a number that deals separately than these others. And then the square root of x to the 6, we could do square root of x squared, square root of x squared, square root of x squared. And then y to the 4th, square root of y squared, square root of y squared. And this would give us 11, x to the 3rd, y squared. And then, like I said, the directions for this one would have said you need to put the absolute value bars where it's appropriate. Now, maybe we don't need them. We do need them on this one. This is a square root, that's an even root, and we have an odd power right there. So around that term, that x to the 3rd term, we're going to need the absolute value bars. Absolutely going to need them. Raise your hand if you got 4 out of 5 or 5 out of 5. Good, there's some tricky stuff going on in here. Okay, how many 3 or more out of the 5? Now we got just about everybody. All right, so like I said, Make sure your name is on those. I want those so that I can take a peek at it and say, all right, here's what we have to talk about some more before we take a test on this stuff. Because we are already kind of starting the, you don't use it, you lose it a little bit from the concept bite. And that was just rules of exponents. But like I said, you guys were doing great while I was walking around. It was looking good. So some things are coming back easier to you than others. And all we have to get through today is the word problem. You know, every section has that. We've got, hey, let's start off with the real basic stuff. Now let's get a little bit harder, and that was where our variables came in. And then apply this to something. If you can work with a formula, you can do these. It's not going to be a big deal. So academics, we're going to use a radical expression. This is still part of our objective that we were going through yesterday, which is just finding nth roots. You know, it's a very broad objective. So some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting the scores is A equals 10 square roots of R, where A is the adjusted score. So not the real score that they got on their paper. That's the one that the formula kicks out so they can get a better grade or a worse grade depending on what's going on. In most cases it's going to be a better grade. And then this one, the R, it says is called the raw score. The raw score is what did you actually get? You know, how many right out of how many total did you get? Now, why does somebody do this? Well, when you go to college, you're going to have a professor that likes to show you just how smart they are by making a test that nobody can get a perfect paper on. You know, there'll be questions on there where you're going, did they even say this ever in class? And the answer, truthfully, will be no. And that's because there are some professors, I remember one of them, he had to take a course in political science as an elective. And he started off the course by saying, I've been teaching here for 30 years and I have only given 2 A's in that time. So those of you that think you're going to leave here with A's, you might as well go drop the course right now. So that was like, okay, do I drop the course? What do I do? And I decided to stick it out. And what happened was he had us do this long paper about, kind of relevant with what we're going to do today, the Cold War at the time. And I had managed to find a book that he had never heard of before, and he was just thrilled with that. So I managed pulling out an A- in the class. But you have teachers like that in college that say, I'm just going to teach you a high level in this class, but I expect you to go to the library and do your own research, to do things outside of class to get an A. There's not many of them, but you'll find one. They'll be there. So here's what they do. They get the test scores back, and it's out of 100%, and the highest score in the class was 60. What do you do with that? You're going to fail everybody in the class? So they do this little adjusting thing. To me, that's just a horrible, awful thing to do to people, and if we ever did that here at Elk River High School, we would say, this is a really lousy test. We better go back and write another one. You know, you want to have a test that the highest level of students in your class can actually get, a perfect paper. So this is what people who want to show you how smart they are do. They say, all right, we'll take this test, and here's what happened to this one. Not too bad, but look at that. That 36 is really, really low, right? It's 36 out of 100. And 90 was the highest. And they want to know what would be the range of the adjusted scores, the one that they would actually put in the books when they said, well, I have to curb this, because if I don't, we've got a lot of failures. Well, we're going to put 36 and 90 in the formula where they're supposed to go. And where they're supposed to go is raw scores. So that means they're going to go in for R. So the lowest score would be 10 times the square root of 36. Oh, well, that's kind of nice. What's the square root of 36? 6. 6 times 10 is 60. So now instead of somebody getting 36, they got a 60, which is still failing, but at least it's better. And then the highest score was a 90. So you put a 90 into that raw score. But the square root of 90 is not something nice. So we'll let the calculator tell us what 10 times the square root of 90 is. So the highest score would be about a 95. And now when he's talking at the water cooler about the tests that his students take, he can say, well, they did all right. Lowest score was 60, highest score was a 95. Yeah, it wasn't too bad. So when they say, what's the range of the adjusted scores? The range is 60 to 95. That doesn't sound so bad. But they didn't mention that they had to adjust them because the test was too hard. So this next one is for you. It says, do this again, but do it knowing that somebody skipped on test day. So they're getting a 0. Find out what would go in the grade book for them. And somebody actually aced this test, you know, got 100%. What would go in the grade book for those people? Chicken wing a different elbow partner. See if they got the same thing you did. Something different from before. Front, back, side, side.
Because if it's the highest, if it's like the highest one is in,
So, did you think you did something wrong when you did this one? They got a 0. They keep a 0 with this formula. And with this formula, if you get a 100, you keep a 100. That's why they use this formula. Do you see how there's no benefit to skipping the test, even if you use the formula to curve it? And there's no benefit to an A person, or, in fact, it's not going to hurt them. This formula won't hurt them if they do get 100% on the test. So this is one of the things that people will sometimes use to figure out, okay, if I've got to curve this, how can I do it? Because, especially at college, what they try to do is this. On the scale of A's, B's, C's, D's, and F's, they want to make a little bar graph that would look like this. Because the belief is that most people are average students. So when they're doing the curve, they're actually trying to get that to hit a curve you saw back in probability and statistics in order to make that work. So that's what that 10 square roots of R is for. I'm going to let you know there's going to be one of these in your homework, but I need you to be careful because they don't give you the raw score for that one. They give you the adjusted score. So put the number in the right place before you do the math. Objective today, same as the others, we were trying to find the nth roots, but find the nth roots with a word problem. 43210, mean how you feel about our little word problem today. Not so big and scary for a word problem, right? Cool. Lots of work time. Lots of time for practice here. And let's see. Not enough problems in the book. So I'm going to have you do a few from the book, and then I'm going to give you a worksheet where we're going to do these. And again, working class. Oh my goodness, you can finish this before you go. I mean, remember, these problems go very fast, they really do.